wire that is 18 inches long is divided into two pieces. The first piece is used to form an equilateral triangle, and the second piece is used to form a circle. Number 1. Write a function to model the area enclosed by the two shapes in terms of the length of wire used to form the equilateral triangle. The perimeter of the triangle is equal to x, the independent variable, which makes the area of the shapes the dependent variable. Because the perimeter of the triangle is equal to x and the triangle is equilateral, each side of the triangle equals 1/3 x. Because the combined perimeter of the triangle and the circumference of the circle is equal to 18, the circumference of the circle is 18 minus x. We must find the area of both shapes to find the combined area. Let's start with the area of the triangle. The formula for the area of a triangle is area equals 1/2 base times height. The base of this triangle is 1/3 x, so our equation so far is a equals 1/2 times 1/3 x times height, or a equals 1/6 x times h. In order to find the height, we must use the Pythagorean theorem, a squared plus b squared equals c squared. To find the height, we will do the Pythagorean theorem for half of the triangle, so a equals 1/6 x, b equals h, and c equals 1/3 x. If you put these values into the theorem, you will have 1/6 x squared plus h squared equals 1/3 x squared. We can simplify by making it x over 6 squared plus h squared equals x over 3 squared. After distributing the square, the equation is x squared over 36 plus h squared equals x squared over 9. Subtract x squared over 36 from both sides to get h squared equals x squared over 9 minus x squared over 36. In order to subtract, we must find a common denominator, so multiply x squared over 9 by 4 over 4. This gives us h squared equals 4x squared over 36 minus x squared over 36, which simplifies to h squared equals 3x squared over 36. To find the height, take the square root of both sides. The height equals x square root 3 over 6. Now we have to substitute our values into the area formula. So a equals 1/2 times 1/3 x times x square root 3 over 6. This simplifies to a equals 1/6 x times x square root 3 over 6. Finally, the area of the triangle equals x squared square root 3 over 36. Now for the circle. The area of the circle is pi r squared, but we need to use the circumference to find the radius. The circumference of a circle is 2 pi r, and the circumference of our circle is 18 minus x. Therefore, 2 pi r equals 18 minus x. To find r, divide each side by 2 pi. The radius of the circle is 18 minus x over 2 pi. Now for the area. Area equals pi times 18 minus x over 2 pi squared. Distribute the square to get a equals pi times 18 minus x squared over 4 pi squared. Put pi over 1 to multiply, and the area is 18 minus x squared over 4 pi. Add this to the equation for the area of the triangle, and the area of the combined shapes is x squared square root 3 over 36 plus 18 minus x squared over 4 pi. Number 2. What is the minimum area enclosed by the two shapes in terms of the length of wire used to form the equilateral triangle? Insert the area of equation into y equals of the graphing calculator with the parentheses as follows, and then graph. You can adjust the window, but here's an example of one that works. To find the minimum, press second trace 3 minimum, left bound enter, right bound enter, guess enter on your calculator. The point should be 11.218, 9.715. Therefore, the minimum area is 9.715 inches squared. Number 3. What length of wire should be used for the equilateral triangle if a combined total area of 17 inches squared is needed? On your graphing calculator, set y1 equals to the area equation and y2 equals to 17. Now graph. To find the intersections, press second trace intersect, first curve enter, second curve enter, guess enter. Do so twice to get both intersections. The point should be 3.66417 and 18.77117. We cannot use 18.771 because we only have 18 inches of wire to begin with. Therefore, the length of wire for the triangle equals 3.664 inches.